protein. So far we discussed about carbohydrates, lipids, then we can start our discussion on protein. Again, this is major nutrients. Proteins consist of the carbohydrate consists of carbon, hydrogen, oxygen as elements, major elements. Protein consists of carbon, hydrogen, oxygen, in addition to that, nitrogen, phosphorus and sulfur. Right? Protein consists of carbon, hydrogen, oxygen, right? In addition to that, phosphorus and sulfur. Phosphorus and sulfur. Right? That is very important thing. Then, if you think primary unit of protein, this is amino acid. Right? Amino acid, number of amino acids joined together through peptide linkage. This linkage is not a glycosidic linkage, this is known as peptide linkage. Peptide linkage. It is different from the glycosidic linkage. Now this linkage is peptide linkage, right? Amino acid joined together through peptide linkage, right, form proteins, right? If two amino acids join together from one peptide linkage, that is dipeptide, right? Like this, there are a number of things. Proteins are macromolecules, large molecules compared to other ones. Proteins are macromolecules. Therefore, like other nutrients, if you really need to understand the behavior, properties of proteins, you have to understand the amino acid. Otherwise, you cannot understand protein. Because protein is collection of amino acid. Protein is collection of amino acid, right? Now, if you take amino acids, there are number of amino acids available in world. Number of amino acids. It is around 200. 200. Around 200 amino acids available in world. But out of 200, for our nutrition, we consider 20 amino acids. 10%. Out of 200, we consider 20 amino acids for our nutrition. This is enough because most of our protein consists of these 20 amino acids. Most of our protein consists of these 20 amino acids. The 20 amino acids are like the alphabet. 20 amino acids are like the alphabet, letters of the alphabet. If you take alphabet, there are a number of letters. If you take single alphabet, A, like this, right? English alphabet, A, B, C, D, E, F, G, H, like this, right? Now, can you give me the number, exact number of words available in the English language? Can you give me the exact number of words? You can't give. But exact number of letters available in the language, yes, you can give 26 letters. Exact number of letters in the single language, most of you can't do it. But English you can do. In singular you can't do. Right? That is a problem. Right? You have to check your status and maintain your status not only in the Facebook, right? Within you. Right? Within you, you have to aware about your language. Right? 52 letters. And one system 52, other one system 54. Right? Number of letters. Rather than English one. Number of letters. Right? Therefore, our language is very important one. Right? But anyway, although we have 52 letters, can we tell? Any expert, any professor, any expert can tell available number of singular words in this language? No. Not only Sinhala and English, Tamil, Greek or any language, there is a standard alphabet. Standard alphabet. Right? But number of combination of those letters create words. Number of combination of those letters create words. Therefore, no one cannot give the number of words available in the system. Right? That is the reality. Therefore, same thing we can apply here. 20 amino acids like alphabet. It is like alphabet. By combining in different ways, it can create number of proteins. Number of proteins. So we cannot calculate. We cannot calculate the combinations. Infinite number of combinations they are, right, to form proteins. Out of 20, 9 amino acids we cannot synthesize within our body, like fatty acids. When we discuss fat, we discuss essential fatty acid. Likewise, we can discuss essential amino acid. Right? I am not going to name essential amino acid because I think you are in grade 7, 8, 9, 10, 11, A level, right? You are cramming essential amino acids, right? Right? Please go through the book or any simple notes. You can extract essential amino acid or you can give the name now, one by one. Right? This is very simple. Right? So those amino acids we cannot synthesize within our body. That's why we name this as essential amino acid. Others are also essential. Sometimes some people may think these are essential, other level are non-essential. No, we can't say like that. Others are essential, but we cannot synthesize. We cannot synthesize that acid within our body. That's why we say this is essential amino acid. This is essential amino acid, right? Right. Then we will think about the structure of amino acid. Structure of amino acid. Before that, you have to identify the amino acid. You have to identify the amino acid. Otherwise, you can't identify the protein. So if I draw the structures like this, R, CH, NH2, CH2, CH, COOH, R. This is structure 1. Structure 2, R, CH, NH2, CH, COOH, CH, R, CH3R. Third, R, C, NH2, COOH, CH, CH2, CH3R. Three options, three structures. You can copy these structures on your note. Now, after copy the structures, can you select amino acids? Can you select how many amino acids are there out of these three? How many amino acids are there? First, you have to copy these structures to your notebook and you can select amino acids among them. So if we take first structure, right, CHNH2 here, amine group is present, right? And CH2CHR carboxylic group is present. This is present, this is common, right? Second one, again amino acid, amine group present, carboxylic group present. Third one, amine group present, carboxylic group present. With respect to the group wise, group amine and carboxylic, all three compounds contain amine group and carboxylic group. So that means all three contain same active groups, right? Then we will think about the positions of that group. In the first compound, amine group and this carbon, but after one carbon, then you can observe the carboxylic group, right? The second compound, amine group in this carbon, and the next carbon attached with the carboxylic group. Third option, amine group and carboxylic group attached to the same carbon. Both amine and carboxylic group attached to the same carbon. So if you think about position wise, there is a difference, right? If you think about position wise, there is a difference. Two positions, but two different positions. When you compare these two, yes, there are same active group, but two different positions. Amine group position is same always, but carboxylic position, three different positions in three compounds. So how do you select correct amino acid? This is the theory, right? Correct amino acid is only 3. This is the correct amino acid. Why? So why did I say like that? Right? In case of amino acid, both carboxylic and amine group should, that is very important, should connect with single carbon. Same carbon, not two carbons. Right? These are acids, but not amino acids. If it is amino acid, carboxylic as well as amine group should join with the same carbon atom. Therefore, this is amino acid. This is amino acid. Right? Now you know what is amino acid. Therefore, we can draw the amino acid like this, symbolized amino acid R C NH2 COOH H. This is the amino acid. R C H C O H NH2. Right? This is the amino acid. Right? In case of amino acid, I repeat it, both active groups, carboxylic group and amine group should, right, fix with the same carbon, not different carbon. Right? So amino acid chemistry, especially we name this carbon as alpha carbon. So when we discuss the amino acid, we name that carbon as the alpha carbon. Right? Right. Now we will see. Now you can identify the amino acid. Now you will see very important point. Right? Special properties of amino acid. R C COOH NH2 H. Sometimes under certain pH condition, this hydrogen can remove as a H plus. Hydrogen can remove H plus. Therefore, this can convert into R, C, H, NH2, COO minus. Sometimes certain hydrogen ions and the acidic pH can join with amine group. Then the product is C, R, H, COOH, NH3 plus. Under two different pH condition, high pH condition, right? This is the condition. Low pH condition, this is the condition, right? This is like that, right? Like that. First, under this pH condition, you can observe anions. Under this pH condition, you can observe cations, right? Same amino acid can convert into either cation or anion depending on the medium pH. Depending on the medium pH, same amino acid, this amino acid, same one, convert into either negative or positive form. Negative or positive form. But sometimes amino acid can show this structure C, R, COO minus and NH3 plus. Both negative and positive charges on the same molecule. In certain cases, both negative and positive charges, right, fit with the same molecule. This molecule type is known as sweeter ion. Is the name? Is a sweeter ion. Sweeter ion. In case of sweeter ion, both negative and positive charges are there. Negative and positive charges. Like here only negative charge. Here only positive charge. But here negative and positive charges are there. Sweeter ion. Right? Right. Now, shall we calculate the number of positive ions or negative ions in the system one by one? Right? What is the total number here? Plus 1. Right? Only 1. 1 plus 1. Right? Total is plus 1. Here, minus 1. Because only 1 minus thing. Here. 1 plus, 1 minus. What is the total? 0. So net charge of this system plus 1, net charge of this system minus 1, but net charge of this system 0. Right? Net charge of the system 1, if we take system 1, minus 1, it is the cation, the anion. Net charge of the system 2, that is cation, that is plus 1. But system 3, positive, both positive and negative ion, sweeter ion. Net charge is 0. Net charge is 0. So when net charge of the amino acid becomes 0, it cannot exist in the solution. That is the important point. When net charge of the amino acid becomes 0, like this, like when the amino acid molecule converts into this form, it cannot exist in the solution, liquid phase. It will rapidly precipitate, coagulate and precipitate. When net charge of the amino acid molecule becomes 0, it cannot exist in the solution phase. it will readily precipitate. Right? It will start precipitating. Right? So that means this point is very important in food industry. Why? If you really need to precipitate certain protein, you have to think about this point. Right? If you really need to precipitate protein, you have to think about this point. This point means actually precipitation pH. So we can use a special name for this pH. Right? At certain pH, amino acid shows anions. At certain pH, amino acid shows cation. But in certain pH, amino acid shows zero charge, that is precipitate. So this pH is known as, very important name, isoelectric point. Isoelectric point. So this is known as isoelectric point of the protein. Right? This is known as isoelectric point of a protein. Isoelectric point of a protein means, right? When you change the pH of the medium, right? When you change the pH of the medium at one pH, amino acid forms negative forms. At one pH, amino acid shows positive forms. Right? At certain pH, amino acids become precipitate. So, right? So, at the net charge negative, amino acid give the one value. Net charge positive, negative, amino acid give the one value. But when net charge zero, that pH value is known as isoelectric point, that is known as pH simple I. pH simple I. Simple I indicates isoelectric point. Right? So now this is the isoelectric point. So what are the industries based on this point? We use practically this isoelectric point in food industry. What are the industries? Especially cultured dairy products. So generally we take milk, right? Fresh milk, and introduce bacteria culture. Bacteria, what is the role of bacteria? Bacteria grow on the lactose and convert into lactic acid. So what will happen to the pH? pH decrease. When it reaches to the isoelectric point of the casein, casein molecule precipitate. Right? So when you introduce the bacteria to the milk, bacteria consume lactose available in the milk. Then as a result of that, lactose convert into lactic acid. Then the important thing is, during this fermentation process, pH of the medium gradually decrease due to formation of lactic acid. pH of the medium gradually decrease. So that pH reach to the isoelectric point, this point of the casein. Right? Isoelectric point of the casein start precipitate. That is the point of manufacturing of yogurt. Not only yogurt, curd, cheese, everything. Right? Soya yogurt also that principle. Protein precipitation, if you require any protein precipitation, you can use isoelectric point. There is a theory behind that. Right? So isoelectric point is around 4.2 in milk. Right? Therefore, if you can reduce the pH of the milk, right, up to the 4.2, you can observe without bacteria, you can solidify the milk. You can precipitate the protein, casein. That is, you can observe at the laboratory. If you really need, prepare a series of acids and take the sample of milk and gradually you can add. Right? When the pH medium, you can measure the pH using pH probe. Right? When pH reaches to the 4.2, you can observe the precipitation of milk. That is the principle behind cultured milk process. Right? Then, if you really need to analyze the isoelectric point, you have to titrate. You can use titration technique to analyze the isoelectric point. We discuss about the amino acid generally, right? Then we think about this part of the amino acid, alkyl group, this part, alkyl group of the amino acid, that is side chain of the amino acid. Basic active groups are carboxylic as well as amine. Carboxylic as well as amine. Right? Carboxylic as well as amine. NH2 COOH. Right? Now we are going to discuss about the alkyl group. Depending on the alkyl group, side chains of the amino acid, right? Certain properties can be changed. Certain properties 100% depend on these side chains because certain side chains are polar. Certain side chains are non-polar. Right? Certain side chains are negatively charged, while certain side chains are positively charged. Right? If you take these side chains, certain are negatively charged, certain are positively charged. So I will give the positively charged side chains. You can observe this side chain in lysine. N you can observe this side chain means amino acid lysine. Lysine contains this kind of side chain. Right? Again, if you observe arginine, this kind of side chain, arginine. Right? This is arginine. This is not arginine. Arginine available, this kind of side chain. Lysine available, this kind of side chain. Right? This is for the examples for positively charged. Negatively charged one, you can take this example. So this kind of example you can observe aspartic acid. Aspartic acid. Right? Here, negatively charged. Another example, glutamic acid. This is glutamate. this side chain available in glutamine acid. Right? Likewise, depending on the side chains, right? Depending on the side chains, you can observe different types of amino acids, and because of the side chains, they show different properties. Because of the side chain, they show different properties, right? So now you study about the active groups of amino acids, right, and side chain of amino acid, right, and the important property, isoelectric property of the amino acid, isoelectric point of the amino acid, and its importance, right? Then we will see what is peptide bond really, right? What is peptide bond? Right. Here I am going to draw the part of the protein using one peptide bond. This is one amino acid C R H, right? Then N H C O C R H. Right. This part is simple from the amino acid, right? So what is the peptide bond? Peptide bond is bond between CO and NH. CO and NH. This is a peptide. Peptide bond. Then we will think about the bond length between carbon-nitrogen. Between these two, bond length of CN bond equals 1.47 angstrom bond length, right? Then bond length between carbon-carbon 1.53 angstrom. What do you think about bond length between carbon-nitrogen peptide bond? This is same as this one, no? Same as another one. So what is your idea? So if you measure the bond length between carbon-nitrogen, normal carbon-nitrogen linkage, 1.47. Right? If you measure the bond length between carbon-carbon in this system, 1.53 angstrom. So what do you think about the bond length between carbon-nitrogen in the peptide bond? Actually, peptide bond length is 1.32. 1.32 angstrom. Less than the CN bond length. Less than the CC bond length. Right? But if you check the carbon-carbon double bond, almost same length. This is equal to the carbon-carbon double bond length. That is this length. If you take the bond length of CC, same length. Bond length of the carbon-carbon, you can have the same thing because of the same distance. So what does it indicate? It indicates peptide bond. Peptide bond shows double bond characters. This indicate our peptide bond shows double bond characters. Right? That means if you take only peptide bond NHCO, right? This can show double bond characters. NCHO. Right? This is negative. Double bond characters. Time to time it can take this structure because of this nature. Therefore, practically, right, it shows bond-wise, it shows double bond characters. Double bond characters. Double bonds are planar. Double bonds are planar. Right? Double bonds are planar. Therefore, it shows cis-trans geometry. Right? Most of the planar molecules containing double bonds shows geometrical isomerism. Geometrical isomerism, that is cis-trans. If the amino acid shows the double bond characters, then it can behave as double bond containing compound. If it is behave as double bond containing compound, we can consider it is a planar compound, right? If it is a planar compound, we can describe the geometrical isomers with respect to that compound. Geometrical isomers with respect to that compound. So geometrical isomers mean cis-trans isomers. Cis-trans isomers with respect to this. Right? Therefore, rather than other types, right, geometrical isomers are common with respect to the amino acid. With respect to the amino acid. Right? Right. If you think about trans and cis with respect to peptide bond, what can you say about H and oxygen? Cis or trans? Based on this diagram, this is trans to each other. Trans to each other, not cis. If it is cis, oxygen should be here, not here. Right? We have to draw the oxygen here instead of here. Now, hydrogen to oxygen trans in this peptide bond. Right? I purposely draw the structure like that. Why? Generally, when we draw the amino acid structure, right? Amino acid structure, peptide bond especially, we have to symbolize that symbols like trans position, not the cis position, because this is a stable structure. Why? So if you try to draw this kind of structure, N, C, H, this one, this is cis form. But because of the size of the molecule, there is a hindrance. This is known as steric hindrance. Steric hindrance, which is created due to the molecular sizes. Steric hindrance actually created due to the molecular size. If it is in the same side, this hindrance is very high. Therefore, instability is very high. Therefore, for the stable format, right, generally N, H and CO exist trans to each other. This is the correct form, correct availability. Right? Correct availability. Right. Then we will think about the structure of the protein. We will think about the structures of the protein. structure of the protein. Now you know amino acid, you know the isoelectric point, right? Peptide bond, properties of the peptide bond, you know the properties of the side chains attached to the amino acid, right? Alkyl group properties. Now we move to the next part of the protein classification. Protein classification. Classification of protein, right? Classification of protein. There are few types of protein. First type, primary structure. Second type, secondary structure. Third type, tertiary structure. Primary, secondary, tertiary. Last type, quaternary structure. Primary, secondary, tertiary and quaternary structures. Now we will see what are these structures. What is primary structure of protein? If I ask a question, what do you think about that? Primary structure of protein. How do you explain primary structure of protein to your friend? Actually, primary structure of protein is sequence of amino acid available in this protein. Sequence of amino acid. That means if the protein chain like this, it is number of amino acids joined together to form protein chain. Like A, B, C, D, E, J, Q, R, S, Y, W, Z, P, H. Number of amino acids joined together. Right? This amino acid order or sequence. Order or sequence, any word you can use. Order or sequence is known as primary structure. Right? You can use different techniques, chemical method, enzymatic method to determine the primary structure of amino acid. This is very important information. Right? If you know the primary structure of amino acid, right, you can work with so many proteins because you know the initial quality of the protein. The very important point is each and every primary structure has two ends. One end consists of carboxylic, other end consists of amino. Therefore, we name this end as N-terminal. N-terminal. Other end as a C-terminal. N-terminal and C-terminal, two terminals with respect to the amino acid, with respect to the protein, right? Protein chain, we can identify two ends. N-terminal consists of amino group, C-terminal consists of carboxylic. N-terminal consists of amino group, C-terminal consists of carboxylic. Right? So these are the two ends. Sequence of amino acid is known as primary structure. That is the primary structure of protein. Right? Then we come to the secondary structure. Secondary structure means this primary structure forms this kind of strand or simple lines, sheet line. Right? This primary structure form loop forming like lamp, right? Or sheet like this. Helical structure or sheet. This is helical structure. This type of structure is known as alpha helix. This is known as beta sheet. Right? So proteins secondary structure, primary structure, sequence of amino acid, secondary structure either alpha helix or beta sheet. alpha helix or beta sheet. Right? Sometimes in certain special type protein contain both in mixture. Certain amount alpha helix, other amount beta sheet, right? But that is special type protein. That kind of protein are known as super secondary structure. Super secondary structure. Right? Super secondary structure. Super secondary structure means in certain cases, certain protein structures as both structures. Generally, secondary structure means either this one, alpha helix, or beta sheet. But in certain exceptional cases, it may contain both parts, alpha helix as well as beta sheet. So these kind of structures are known as super secondary structure. Right? That is the secondary structure. Then tertiary structure. Tertiary structure means little bit coil, this form. Right? This is alpha helix. Alpha helix form tertiary structure. Like this. Right? You can observe bonds in between these strands, within these loops. You can observe bonds. Different types of bonds can be formed. Within the strand, different types of bonds can be formed to strong the tertiary structure. Among these bonds, the most important bonds are ionic bonds. Some are ionic, some are covalent. I think covalent you know. Covalent means sahabandhana. Ionic means ionica bandhana. Ionic, covalent, van der Waals forces. Van der Waals forces. Ionic bonds, covalent bonds, van der Waals forces, and sometimes electrostatic attraction. Electrostatic attraction. Some are disulfide linkage. Some are non-polar linkage. Some are hydrogen bonds. Number of interactions you can observe within the system. So difference between tertiary and secondary structure. Right? Tertiary and secondary. Secondary structure, you cannot observe this kind of cross-link within the stream. Within the system, you cannot observe this kind of cross-link. Right? But tertiary structure, you can observe cross-link formation. That kind of cross-link, ionic, covalent, van der Waals, electrostatic, disulfide, non-polar, hydrogen bonds, like different types of interactions, bond formation you can observe on tertiary structure. Tertiary structure. Right? Therefore, when we discuss the protein structure, protein denaturation and everything, the most important part of the protein structure is this one, tertiary structure, not the secondary or primary. Not the secondary or primary. All property of the protein determined by the tertiary structure. All property of the protein determined by the tertiary structure of protein. Right? Right. Then we come to the quaternary structure. So what is quaternary structure? Quaternary structure means at this level, certain specific groups of amino acids join together to form one duty. Special group of special amino acid group, special protein groups join together to perform one duty. That is quaternary structure. For example, hemoglobin, right? Certain groups of globulin proteins join together to form one protein, that is hemoglobin. That is a quaternary structure, right? Quaternary structure, hemoglobin, and myoglobin, another one. Certain groups of globulin protein again join for the another purpose, that is myoglobin. That is quaternary structure, right? So likewise, we can describe four structures for the proteins. We can identify four structures for levels of proteins: primary, secondary, tertiary, and quaternary. Primary is actually sequence of amino acid. Secondary is alpha helix or beta sheet, alpha helix or beta sheet. But we cannot observe interaction between the same strand in alpha helix in secondary structure. In certain cases, both types, alpha helix and beta sheets, both types in the same protein. That kind of structures are known as super secondary structures. Super secondary structures. Then we can come to the tertiary structure. Tertiary structure means the form strand very strengthened by the interactions. Interaction means intermolecular bonds. So these bonds are ionic, covalent, van der Waals, electrostatic attraction, disulfide linkages, non-polar bond, and hydrogen bonds like bonds. Right? You can observe this kind of bonds within this system in tertiary structure of protein. This is very important. All protein quality depends on this structure. Because when you think about denaturation, we have to describe this structure. Denaturation means breakage of these cross-links. Right? Right. Then next we come to the quaternary structure. Quaternary structure means a set of the protein, group of the protein, join together to form single duty. That is quaternary structure of the protein. That is quaternary structure of the protein. Then we will discuss about the protein denaturation. What is denaturation? Protein denaturation. So when you expose protein to the high temperature or different pH conditions or certain inorganic salt, right? Protein, tertiary structure of the protein denature. That means certain bonds available in the tertiary structure can be break, right? Then you cannot expect the same property from the protein after denature. After denature, right? Amino acid profile is there. That is not a big problem. Amino acid profile is there, but for the certain biochemical actions, we require special shape, special structure. So, special structure lost due to denature. Therefore, protein quality lost. Right? Quality of the protein may lost. Right? This is, we can look in 2 points of view, not single point of view, 2 points of 2 sides. One side, due to denaturation of the protein, we can observe operational changes. Operational changes of the protein. That is one. The second one, molecular changes. Due to denaturation, we can think about operation changes. Other one is molecular changes. Operational changes mean certain functions cannot perform. Operational changes like that. Certain functions cannot perform due to denature. Because certain functions specially related with the structure. Once the structure denature, the problem become very high. Right? Like, especially if you take enzyme, all enzymes are protein. Right? So generally enzyme substrate activity, right, we explain with the lock and key mechanism. Lock and key mechanism is we are thinking about the shape of the enzyme, active sites of the enzyme. Right? So if you change the shape, what will happen? We cannot use that compound as enzyme. That is operational change. That is operational change. Molecular change means sometimes when you apply those conditions, high temperature, inorganic, organic salt, right? The bond system, interactions, right? Intermolecular bonds destroy, right? The shape of the molecule change. Because of the shape change, all molecule can be changed. That is molecular change. Initial shape can change one. After removing the side linkage and cross linking, again shape becomes the second one. Right? It's some types of off loop, like this. Right? Therefore, that is the molecular change. So, due to the denaturation, we can expect operational changes of the protein as well as molecular changes of the protein. So, most probably, physical factors like temperature, pH like this help denature the protein, right? High temperatures like condition. When you take the chemical factors, there are urea-like organic chemicals, sodium bromide, sodium thiocyanide, sodium cyanide like sodium iodide like inorganic salt, right? Denature the tertiary structure of the protein.